G'day, this is our second lesson. Now I'm seeing that there's a massive lag, and I'm sorry about that. I don't know how to fix it just yet. But this lesson is going to be on quadrilaterals. And it's a massive, massive topic. It's much bigger than triangles because you've got so many different other types of quadrilaterals than you do triangles. And you're lucky in that if you're probably good at maths, it means that you've recognized these things already. And you might intuitively know most of this sort of stuff. Whereas if you don't and you hear anything new here, that's a great thing because you can learn it and you're going to get better at this whole topic. And first and foremost, we've got this idea of a convex and a non-convex quadrilateral. Now, at its most basic, when we're talking about quadrilaterals, we've got quadrilaterals that have pointy, all the outer ends are pointy. And here we have non-convex quadrilaterals where we've got one angle that points inwards. Now, sometimes you might hear them as concave. There's a concave angle, and concave means goes in. But a convex quadrilateral is pretty much the one that we're going to be dealing with the most because we're basically going to be dealing with our regular shapes. If this is new to you, feel free to pause and have a read of these. Now, there are 6 special types of quadrilaterals: a trapezium, a parallelogram, rectangle, kite, square, and rhombus. And they're the ones that we learn a lot about, particularly in Year 8, Year 7. Now, what makes a trapezium? A trapezium is the most basic of the lot because the only definition that it has, or the only thing that makes a trapezium is that it's got one pair of parallel lines. None of the angles are regular. It's just got one pair of parallel lines. Whereas a parallelogram, on the other hand, has 2 pairs of parallel lines. And as a result of having 2 pairs of parallel lines, it's also got opposite angles that are equal. And we'll get to that later. Now, this differs very, very slightly from a rhombus, which also has 2 pairs of parallel lines, because a rhombus also has all sides that are equal, or all 4 sides that are equal, like a square. Effectively, it's just a square that's been... Let's do it again because the lag. Let's see if I can do it long enough for the lag to kick in. So, a rectangle is basically a parallelogram that has all 2 pairs of parallel lines, opposite sides are equal, and angles that are all 90 degrees. In other words, 4 right angles. And a kite, which is kind of another bit of an odd one, like a trapezium, just has 2 adjacent sides that are equal. In other words, 2 sides that are next to each other that are equal, 2 sides that are next to each other that are equal. Now, these are the bits that might get you, because we know now that the sum of the angles of a quadrilateral add up to 360 degrees. But it's these bits that tend to confuse people when it comes to quadrilateral geometry. Like I said, trapezia are the easiest ones because they have no axis of symmetry. You've only got one pair of opposite sides. But rhombuses and kites are quite special in that the diagonals, if you go from diagonal to diagonal, draw a line, diagonal to diagonal, draw a line, those will always meet at a right angle. And you'll see down here, they'll always meet at a right angle. They'll also have opposite angles, or a pair of opposite angles that meet. They don't have an axis of symmetry. Parallelograms, you'll see if we draw the diagonals, they don't actually meet at right angles. And so that's the big definition. A lot of people confuse parallelograms with rhombuses as a result of that. If you want, or you're not sure on any of these, please pause and have a look because I'm not going to go through all of them in this video. Otherwise, the video will be way, way, way too long. All right, let's move on. Now, if we look at rectangles and squares, a rectangle is very, very similar to a parallelogram, except obviously the corners are right angles, and they do, like a square, like a parallelogram, I mean to say, they do bisect. The diagonals do bisect each other. In other words, cut each other into equal halves. And because of the right angles, all of these are actually equal in length, which is quite fascinating. It's the same with a square. All of these are equal in length, but like a rhombus, they intersect at right angles. It's funnily enough, the square is a very, very simple shape, but it's also the shape with the most information about it. And so a lot of this you're going to do intuitively, but some of it might be worth, again, pausing and having a bit of a look over this one. Now let's have a look at some questions. If we have a look at some questions, this one here, A, this is probably the simplest of the lot, because we look at it and we say, oh well, the sum of the angles of quadrilateral are going to add up to 360, and so we see angle M degrees is 360 degrees minus 93 degrees minus 125 degrees and minus 78 degrees. Let's just type that into our calculator. 360 minus 93 minus 125 minus 78. And so M has to equal 64 degrees. Now, what did we learn last video? We have to put our description. Sum of angles of a quadrilateral. Now here, this is a parallelogram. This is one of those things that you either know or you don't know. Opposite angles of a parallelogram are equal. Straight away, if I see that, I know that that's going to also equal d degrees. And that's nice because that is a straight line. And so they're going to add up together to 180. So I know angle CDA equals 180 minus 75 degrees, which is 105 degrees. And what's my proof? My proof is supplementary angle. And then I also know that angle, therefore, angle ABC equals 105 because diagonals of a parallelogram. Now, how do I know it's a parallelogram? Sorry, I should have done this at the beginning. Two pairs of sides that are parallel. Just going to do this one very, very quickly. Now, we see that this has two sides that are equal, this triangle here, so therefore it's an isosceles triangle. So this angle and this angle are equal. So that has to be 70 degrees. And if that's 70 degrees, it's a straight line. That has to be 110 degrees, because they're going to add up to 180. And therefore, the sum of all of these four are going to add up to 360. So I've just worked, sorry, that was off the page. I've just worked through this in my head, but let's write it out now. So angle ABE equals 70 degrees, isosceles triangle, and then I know angle CBE equals 110 degrees, I should say 180 minus 70 degrees, which equals. You might notice that I just changed scenes. The bell went, so I had to move, sorry. But let's carry on. 180 minus 70 is 110 degrees, and so we see CBE is 110 degrees. And now we know that BED, or angle BED, is 360 minus 110 minus 85 minus another 110. Let's whack it into our calculator. 360 minus 110 minus 10 minus 85, and we get 55 degrees. I better move because these people are coming in.